Hi mate, my name is Ngoc Hieu Pham. I have a background in civil engineering and have earned my PhD from the University of Sydney, Australia, where I focus on cold-formed structural members. My research primarily covers cold-formed steel and aluminium structures in theoretical analysis, experimental work, model simulations, and design. I have also been promoted to associate professor in cold-formed steel and aluminium structures. My PhD research was considered the first project in the world to study cold-rolled aluminium section. This is a new structural product introduced by Abaqus Corporation. The manufacturing of this product is substantially faster and far less energy demanding than traditional ones. Its application has reduced labor and material cost and construction time. My simulation model was developed at present in one of my publications at the Teamwork Structures with the title Member Capacity of Cold-Rolled Aluminium Alloy Channel Columns Part 2 Numerical Investigation and Design. Channel sections were used in this experimental program, and here is an actual experiment. The boundary conditions allowed the end section to freely rotate around the minor axis. The measured stress and strain from the given test were converted into the two stresses and two plastic strains. In terms of geometric imperfection, the measuring imperfections can be incorporated into the finite element model as presented in my publication. Incorporation of measured geometric imperfections into finite element models for cold-rolled aluminium section. Here is an Abaqus model, and you can see free and prevent rotation condition were used for the minor and major axis respectively. Pattern stone was also considered in this model. It will include the specimen, pattern stone, plate 2, plate 3 at end A and end B. So I will show you the step-by-step to build the model from Abaqus. It will have the 5 parts for specimen C250, 3 meters, pattern stone inside, pattern stone outside, plate 2 and plate 3. Imperfection values were added into input file by following the procedure at present in one of my publications at present previously. So you can see the imperfection will include for deformation on the web, deformation on the flange and the lip. The first one, you can see a local buckling will appear on the step 25, so you can see some local deformation on the web. Also, the specimen was bent. At the end, the specimen will failed due to the interaction between the local and the global buckling. You can see in the step 45, the specimen will bend and have an interaction local on the web. The model will be verified with the test results as shown in this graph. Thank you so much for your attention.